thinking styles. Creative people often question conventional wisdom, assumptions and rules. Okay. Because of this, creative people get into conflicts with society around them. I am not suggesting it to you that you should start fighting with your friends and all that, but generally these are the characteristics of creative people. So, to be creative, one needs to be persistent, you should be at it, you should not give up. Okay. That is why you have to be tenacious, you have to be uncompromising, you have to be stubborn, you have to believe that it will work and keep on working at it. Arrogant, I put question mark. There is a thin dividing line between arrogance and self-confidence. So, you can be arrogant in homeopathic dose, but not in allopathic dose. Okay. Hard work. Okay. Hard work is very, very important. There is something called the 10,000 hour rule, which was first proposed by Herbert Simon, who is a Nobel laureate, who said that it takes 10,000 hours of extensive training to excel in anything. Bharatanatyam, cricket, tennis, whatever. You have to put in 10,000 hours of quality time before you can make a mark. Okay. So, the reassuring thing in this is, contrary to popular perception, it is not innate talent or genius that alone matters. If you are having above average intelligence, then if you put in this 10,000 hours, anybody can become an expert. All these great people who are thinking, right, Mozart, A.R. Rahman, Vishwanathan Anand, Bill Gates, all these people put in 10,000 hours in their respective fields before they became famous. Rahman started learning keyboard at the age of 3, right. So, this so called, it actually debunks this so called genius theory. Lot of it is only perspiration, just hard work. Okay. So, the most reassuring, I come again, is hard work alone matters, which means anyone can do it. Basically, do you have the tenacity? Do you have the tenacity? Okay. Are you ready to run this marathon steadily without giving up? Okay. If you put in this 10,000 hours, you can be a master in any field. Okay. What exactly is this rule? Okay. It is so simple. It takes approximately 10,000 hours of deliberate practice study to master a skill or area of research. Okay. So, if you practice tennis for 3 hours a day, it will take about 10 years for you to become a champion in school or district or whatever. It may be the same the case with karate, Bharatanatyam, whatever. Okay. Violin or any instrument, whatever. Full time employment, if you spend 8 hours, so that it takes about approximately 5 years. That is why they say to become associate professor, you have to be assistant professor for 5 years. 5 years is also the time people get their master's degree, MSc, MA. So, in 5 years you would have put in some 10,000 hours in that field. No, many of your research students put this 10,000 hour rule. If you spend 10 to 12 hours a day, 6 days a week, leave the Sunday for your personal things, you want to do sport or you want to watch movie, whatever, or you want to just sleep off in the afternoon. If you spend about 60 hours a week, it takes 3 to 4 hours, 3 to 4 years before you get that vision, darshana, and that you say that yes, I am completely confident about what I am doing, I need my PhD now. Okay, and the guide also says, okay, you are ready, now please go out and conquer the world. Okay, you just get past your guide in that field and then you talk more confidently. So, I say PhD is also about this angle. Okay, initially you will say good morning sir, then till compre it is like this, then slowly it become like this. Then first paper it is like this, when you are finishing it is like this. Okay. So, that angle, that theta, PhD is all about the theta. Okay. Okay. Professor Anders Ericsson of Florida State University has also done a lot of work on this subsequent to this Herbert Simon's proposal. There is a good chapter on psychology of learning and motivation in Academic Press, volume 16, you can take a look at this. And a very popular book on this is by Malcolm Gladwell. His book, the title of the book is Outliers. He published it in the year 2008, and he looks at the success of Mozart. Okay, Mozart, Beatles, Bill Gates, all chess grandmasters. He has conclusively established that all these people have spent 10,000 hours before they became famous. Okay. So, therefore, hard work is the key. First you have to acquire knowledge, then hard work is the key. Okay. Actually, if you look at the progress of science, science has progressed through hard work, failures and frustrations. First time when you are writing a computer program, if it works, I can give it in writing that you will get absurd results. When it first the program you will not be able to compile. Then you will be able to compile, you will be able to run. When you are running, it gives garbage. Then one stage will come, I have done everything. This stupid fellow is not giving the correct answer. Okay, that peak of frustration. At that time, you just take a break and visit a temple, or just take 3-4 days break, do something else. Then when you are taking bath, or when you are reading the newspaper, when you are watching a movie, in line 542, I didn't put the square root instead of the. You will realize, you will come back and then it will start working. Okay, so nobody gets it right. So if you look at some particular ex professor, 450 paper, what a great person he is. All people who have achieved this greatness have also, those people also have rejections. You have to talk to them. But the thing is, even after this rejection and all that, they are not giving up. You should continue. See, when you write, I have said this in my Joy of Research book also. When you write 10 papers, 1 or 2 papers will get rejected, because it is statistical. What is the probability of acceptance? For example, I am a reviewer. If I get to review 10 papers, I reject 2 or 3 statistically. So my probability of rejection is 0.3. Okay. So some other process may be 0.4. So if your paper is reviewed by 3 professors, find out the joint probability of acceptance. For the first referee to accept, it's 0.7, second referee is 0.7, third. So your joint probability is 0.7 into 0.7 into 0.6, which is a low quantity. And then when you write more and more papers from our group, some paper will get rejected. You do not worry. So long as it is original, you have done the experiment, you have got correct results, then the contribution is something very subjective. Different people will. It is just that the set of 2 or 3 people viewed your paper differently. So you should try in some other vehicle. So if you are confident that it is original, it is not copied, there is no plagiarism, you have put in your hard work, then finding the right vehicle for this thing is so easy now, because you have got so many journals. Okay. So just like a mother giving birth to a child, the most important thing is you have done your part, and that baby has come out, the paper has come out. Then we will find out something. We will find out some mechanism. So that joy, that thrill is already there. You already done it. You feel, yes, it's good. You feel, yes, it's good. My hard work, everything is there. We'll find a journal to accept it. Okay. So the human element of these frustrations, how many times the guide corrected, or how long it has taken, how many test tubes are broken, how many these things, the voltmeters went off, okay, how many times the program cupped, all these things are not seen, because there is no time for the reviewer, or there is no time for the reviewer or the editor or the reader to look at all this. Why? The society attaches too much importance only to success. Okay. So if you want to know how science has progressed, you have to look at the biographies of scientists. Benjamin Franklin, you will get an idea of what is, or Thomas Alva Edison. Then you will understand the trials, the tribulations, and the failures which they went through before they could turn into success. Therefore, we often correlate hard work with success. If it is not successful, there is no hard work, but it is a dangerous correlation. If somebody has not scored marks, we automatically conclude that he has not studied well. There may be many other reasons. Okay. So this is sometimes a tragedy, but we have to live with this, because it is a part of us. We are part of the system. We have to live in this society. Okay. Let's now discuss about motivation. Motivation sometimes can be a big problem, particularly for research students, because we go through phases. Okay, where sometimes the motivation is very high, sometimes the motivation is moderate, sometimes the motivation is very low. Okay, whenever the motivation is very low, only during those periods you require something, so that it gets back to normalcy, and then because you have to be motivated constantly, and you have to be self-motivated. Okay, because motivation propels hard work. Okay, so how to stay motivated is very, very important. Okay. Motivation propels hard work. There are 2 kinds of motivation. First is extrinsic. Okay, so you want a reward, you want money, you want praise, you want promotion, you want prizes, fame. All these are extrinsic motivators. If you get that, then you will work more. You will work more. That is okay. That is called. These are all extrinsic motivators. Okay. The most difficult and the more important of the 2 is basically the intrinsic motivation where you set your own goals, achieve your goals, and then don't stop there, set new goals, set new goals, and constantly you are propelling forward. This is intrinsic motivation. Highly creative people, the intrinsic motivation is very high. Therefore, you enjoy what you do. The sheer joy of solving an unknown rider. When you are in 9th standard, you want to solve an unknown rider. There is no prize, there is no motivation, and you are struggling with that for 2 hours. You are struggling with it, doesn't come. Then finally, when you get it, okay, then you put this is theta, that is theta by 2, sin theta cos theta 2, sin theta cos theta secant theta divided by 2 multiplied by sin theta divided by sin theta. Finally, LHS equal to RHS proved. Okay. Then you get that eureka feeling. Okay. That eureka feeling is not related to money, is not related to degree, it is not related to price. Nobody will. That is your own feeling. Okay. At that time, your mother might have kept bone vita, all that, you forgot all that. Even food was not important, sleep was not important. In fact, you were not conscious about your body also. You are just freaking out. It is just your mind which was working at that time. That means you are at the peak of your intellectual abilities. Okay. So the challenge and the skill got balanced, and a sense of timelessness set in your activity. You really that time became infinite at that point in time. You are not looking at even the watch. Okay. So if you are intrinsically motivated in many of your activities, you can reach that peak levels of achievement. In very highly creative people, B is not so important as A, but initially you will start with extrinsic motivator. The same thing with prayer. When you go to a temple, what do you ask? Initially, I want this, I want that, I want that. Whether God will give or not give is not this thing. Okay, that is another point. If you really believe so deeply, then at some stage you will understand what is it you will not give, which I deserve, if you don't ask. Even if you don't ask, if it has to come to me, it will come to me. So your own ideas about prayer may change, right? Okay, I will just come, I want to see you. Today is advance heat transfer, so many coconuts I will break. So it is not an insurance policy, no. Why you should solve your advance heat? You study convection and conduction properly. Environment, a conducive environment is a genuine plus, okay, but it is not absolutely necessary. Srinivasa Ramanujam, FRS, one of the India's greatest mathematicians. So he was born in Kumbakonam, and most of his life he went through a lot of struggle. He didn't have access to journals and this, right? And then he was not in a big city and all that, but still under these adverse conditions, the best science came out of him. The best mathematics came out of him. Okay, so sometimes adversity brings out the best in a person. Okay, so you should not say I will put these. I want a petaflop machine. I want so many this thing. I want such a big RAM. Only with all these things I will work. Okay, even if you don't have this, what are the other alternate ways? What are the other ways of seeking solutions to these problems? Then it will make you more and more creative. Okay. Role of stress in research. The first thing is you should be somewhat unhappy about your current state. If you are too unhappy, then you will sit in the hostel room and you will not come out. That is the extreme case. But you should have some this thing. Oh, it is not good. It is not good. Okay. There should be some optimal unhappiness with your current state, which will propel you to improve and move forward. Okay. So hence progress is all about optimal disenchantment. Okay, optimal unhappiness and channelizing this disenchantment. So achievement is all about optimal nervousness. You should be optimally nervous, you should be optimally stressed, and then with that, this propels you to work harder. Okay, stress is required for bringing out the best in us. U plus stress. U is good. So there is also something called good stress. For some of you, this may be news. You have good stress and bad stress. So stress by itself is not stressful until it becomes distress. I have confused you enough? Okay. Stress is not stressful until the stress becomes distress. So there is a little amount of pressure, a little amount of stress will make us work better. Okay. So This is a human function curve. This is called the Yerkes-Dodson curve. This is a Journal of Comparative Neurology and Psychology published in 1908, where they did studies on rats, and then they gave electric shocks to rats and asked the rats to do some activity. So, okay, rats were asked to do some activity or exercise or whatever. Okay, so that was the target. I mean, there is a sort of activity, and this was benchmark. And now they figured out that if they are not stressed at all, if they are in hypo stress, then the performance is very low. The y axis is performance, x axis is pressure. When they are in U stress, when they are reasonably stressed, they did very well. Okay, and then once they are overstressed, too much of electric shock, again the performance goes down, and finally distress, and finally it can even lead to death and so on. This is now, so this has been mapped on to a human performance curve, and they say human performance curve also resembles this. So if you are extremely stressed, at the same time you are not stressed, under both these cases the performance will be very less. You should be reasonably stressed, you should be in the U stress to bring out the best in you. What is the U stress for you is something which you will have to introspect and figure out. This depends on different people, or how many activities you can take at the same time, okay, how much time you want to sleep, how much time you want for leisure, how much time you will devote for research, how much time you will devote for family, whatever. So you will have to figure out your U stress point. Okay. Role of hard work we have already seen, oft repeated hard work is the key. Even so, this can never be overstated. Even if we say 100 times, we cannot say that it is overstatement, because it is new evidence only confirms this more and more. Okay. Now, how does creativity occur? The conception of a new idea often occurs in intuitive flash of insight. Suddenly some insight comes that I have found the answer to this problem. Sometimes it comes, it can come when you are not in the lab, it can come when you are not in the experimental setup, it can come in summer when you are jogging, or it can come when you are watching a movie or in your bus or something, where more or less the complete idea is revealed to you. But it does not mean that mathematically you can prove, or when you do an experiment you can get this, but sometimes that intuition tells you where more or less the idea is completely, in which more or less the complete idea is revealed, it is not related, the complete idea is revealed. Okay. In scriptures we call it as darshana, or we call it as darshana, okay, the darshan, which you say temple darshan, like darshan means you have that vision, with that vision of that heat transfer in something, fluid flow or something, you have a complete idea of what that. After that you have to note down and jot down, and then you will have to work hard to this thing. See, Max Planck got this in 1901, okay, IB lambda, the black body distribution, the spectral black body radiation, it is C1 lambda to the power of -5 divided by e to the power of C2 by lambda t minus 1. Some people already figured out C1 lambda to the power of -5 by e to the power of C2 by lambda t. Max Planck figured out that e to the power of C2 by lambda t, if I put -1, then exactly that theory was matching with the experiment. So he got that darshana, that is a correct black body distribution. He published that paper, it was accepted, but that bothered him, why that -1 is coming, from where that -1 came. Then he figured out if he has to go back to how to get that -1, he has to find out that E is equal to NH nu, E is equal to H nu, E is equal to NH nu, or S equal to NH nu. Energy transfer can take place in finite multiples of H nu only. It should be NH nu, where N can be an integer. Therefore, H is a fundamental constant of nature which cannot asymptotically approach 0. It is 6.627 in 10 to the power of -34 joules second. So this announced the birth of quantum mechanics. Okay, but first he got the idea, it was just a curve fitting idea, he just got this darshana, oh I put -1. So that -1 got him the Nobel Prize, but it took 17 years for him. 1901 was this thing, and then he worked, and then he proved, and then 1918 quantum statistics was his Nobel Prize. Okay, so then Einstein, other people have worked together, and then you know now, okay, this can also be used for splitting the atom, E is equal to mc square and all that, right. So when you are doing your research, when the darshana comes, take a notebook and write down this idea. Suddenly in your heat pipe you get a brain wave, then you write it down. Then you have to logically follow it up. It may cup also, does not matter. Okay. Then what is the lesson you have to learn? If some brilliant idea is coming and you work on it and it does not work, Then slowly what you learn is, many times brilliant ideas will come, but which of these brilliant ideas I have to pursue is something you will have to figure out. Sometimes, so you will say that next 2-3 weeks I will work, if it is not coming out, I will discard. So you will have a mechanism by which you will judge, this is the path I will take, I will spend 1 month, if it is not coming, I will go to some other path. You should have your own multiple backups, second line of defense, third line of defense, you should internally evolve all this, alright. Journal publications do not reveal the full story. A scholarly publication, the final result can lead to misunderstanding about science is actually accomplished. Abstract, introduction, literature survey, experimental methodology, results and discussion, conclusion, references, in between nomenclature. How nicely he got it. But how much suffering the authors went through to get that paper, that we don't know. Because that is a way, because everywhere there is people don't have time, reviewers don't have time, people don't have, it costs a lot of money to write your own story and all that, right. The pains, frustrations and failures are not reported, okay. So it makes people feel that progress is very uniform and linear. It is not the case, okay. Let us look at this. Typical progress in research follows what is called a log sigmoidal curve, okay. In the initial years your progress will be very less, you should have patience. Then suddenly the graph takes a turn, isn't it. The graph takes a turn, okay, where you get a rapid progress. Then afterwards, if you keep on spending more time, again the progress is very less. Therefore, initially 1, 2, 3 years, whatever, you're learning the science, you're learning your field, you're going through your qualifiers and all that, then you're trying to write a program or you're trying to develop a setup, it is not working, some John is not there, or some workshop something is not there, or something is not moving, somebody is not signing, so many things are there, but after some time suddenly the floodgates will open. One day to your surprise you will see the experiment is actually working and it is giving good results, the program is actually working. Then you should capitalize on that and try to extract maximum. Then after that again milking it dry is not a good idea. I will write the 4th paper, 5th paper, 6th paper, then reviewer will say I do not want any more paper on this okay. So this is the right. So initially if it is not working, do not worry, give it some time, okay. What is the principal way for occurrence of creativity? We should also look for alternate ways in which you view a phenomenon, okay, or how do you rephrase a question, okay. For example, you know that you want to prove that root 2 is irrational. How did you do it in mathematics? If you want to prove that root 2 is irrational, we assume that root 2 is rational, that is root 2 can be represented as p by q, okay, where p and q are integers. Then you start working various operations, finally it will lead to some absurd conclusions, which is not correct. Therefore, if this is not correct, you go back and find out where you make the mistake, you figure out that all the steps are correct. So what is wrong? To assume that root 2 is equal to p by q and is rational was wrong, therefore root 2 is irrational. This is a way of proving. This is called reductio ad absurdum, reducing to absurdity. So used by the ancient Greece. This is an exercise in logic, okay. So in your this thing also you have a multi-objective optimization problem. What are the different ways in which you can pose the problem, or you want a figure of merit for the performance of your device. It could be a solar collector, it could be a heat pipe, or it could be a impinging jet, whatever. Can you think of some other this? Traditionally so many things are used. Can you deviate and come out with a new performance metric? Think about it, okay. And then literature, everybody says Nusselt number versus Reynolds number. You keep plotting Reynolds number, as Reynolds number increases, Nusselt number increases. What else will it do? What a brilliant conclusion. So we should not state the obvious, it is already known. Okay, we should say something. So that is what we say, no? Dog bites man. What is news? Man bites dog, that is news. How your results and discussion conclusion will be like man bites dog. Alright. Contrary to popular belief, as I reduce the tube diameter, though the pressure drop increases, the heat transfer is increased significantly, therefore heat transfer to pressure drop is increasing, therefore it is more advantageous to use a smaller tube diameter, and then people, what is he saying, what is he saying, what is he saying? Surprise, you unsettle all the people who read your work. Don't allow people to read your things in peace. That should be your goal. Okay? Reductio ad absurdum is clear, right? Getting the right problem to solve in research. So the happiness comes out of creativity, because it gives you a sense of achievement or accomplishment, that you are able to do something that is a contribution. You are contributing something, or you are able to find out something which was not there. It comes out of that. You don't even want that. What is it? Where do you want to get happiness from? Otherwise, you tell me. No.
It is intrinsic in.
Yes.
The joy is intrinsic.
Yeah, the joy is intrinsic means because you have improved over what you are thinking you can achieve. You have improved compared to your present level. So far you are not able to solve this unknown radar. So far you are not able to. You are improving. Through this thing, other things may also improve. That we don't know now. But you get some sheer joy out of finding the unknown. Darkness to light. Asatoma sargamaya tamasoma jyotirgamaya. I mean, it's light. From darkness it is light. When you're finding something new, it is like 1000-watt bulb, isn't it? Correct? Getting the right problem to solve in research. Okay? It is easy to ask questions that are trivial to solve. Find the inverse of a 3x3 matrix. Everybody will solve. That is not a PhD problem. It is also easy to ask questions that are extremely difficult to solve. PhD problem, using thermodynamic arguments. Prove that God does not exist. Can that be given as a PhD problem in thermodynamics or radiativity transfer? Okay. Or I'll develop a new theory for the evolution. High risk problem, no? Okay. It's surprisingly difficult to find questions that lie in between these two extremes. You ask the right question, you work on this question for 3 to 5 years, you get a good answer, you get a couple of publications, you get your PhD. That is the right problem for research. Are you getting the point? That is surprisingly, and if you are an academic, a full-time scientist or a professor later on, how to constantly generate these questions which are neither easy to solve nor difficult to solve, but are worth solving. So it's a challenge. Okay. So this Sir Peter Medawar, he got the Nobel Prize in 1960. So this is he talks about the return in investment on working on a research problem, that is a payoff y-axis, and the x-axis the difficulty level. If the difficulty level is very low, the return is very low. If the difficulty level is very high, the return is also very low, because you may not be able to solve it. But if it has the right difficulty level, then the return is very high. That is indicated in the gray area, that is called the Medawar zone. So what is your Medawar zone in your field of research? You'll have to figure out. Okay.